Look up at the night sky. Every star you see belongs to our galaxy, the Milky Way, a majestic spiral of hundreds of billions of stars, gas, and dust. It's our cosmic home. But you know, we humans are a curious species. We've always looked beyond the horizon, seeking new lands and new knowledge. Now we set our sights on a truly mind-boggling goal, to leave our galaxy and explore the vast universe beyond. Imagine our galaxy as a vast island, an oasis of stars and planets in the cosmic ocean. For millennia, we've explored our island, sailed its seas of stars and mapped its constellations. But the universe is filled with countless other islands, galaxies separated by unimaginable distances. Can we build a ship strong enough, fast enough to cross that ocean and reach another shore? The challenges are immense, yet the human spirit thrives on challenges. We're drawn to the unknown, driven by the thirst for discovery. The dream of leaving the Milky Way, once the realm of science fiction, is now a question that occupies the brightest minds in astrophysics. It's a journey that begins with understanding the true scale of the universe and the nature of space and time itself. The distances between galaxies are staggering, almost impossible to grasp. Even light, the fastest thing in the universe, takes time to travel these vast expanses. We use light years to measure these distances. The distance light travels in 1 year. Let's take a journey to our nearest galactic neighbor, the Andromeda Galaxy. It's a beautiful spiral galaxy, even larger than our own Milky Way. But here's the catch. Andromeda is 2.5 million light-years away. If we hopped in a spaceship traveling at the speed of light, it would still take us 2.5 million years to reach our destination. To put that in perspective, imagine shrinking our Milky Way galaxy down to the size of the United States. On this scale, Andromeda, our closest galactic neighbor, would be about the size of the Moon and located roughly 75,000 miles away. Even our fastest spacecraft like Voyager 1, which is currently hurtling through space at over 38,000 miles per hour, would take tens of billions of years to reach Andromeda. That's far longer than the age of the universe itself. Clearly, conventional space travel won't get us to another galaxy anytime soon. We need a more radical approach, a way to cheat the cosmic speed limit. Imagine folding a piece of paper in half. Now imagine poking a hole through the folded paper. You've created a shortcut, a way to travel instantly from one side of the paper to the other without traversing the entire surface. This, in essence, is the concept of a wormhole. Wormholes are theoretical tunnels or shortcuts through space-time, connecting two distant points in the universe. While they might sound like pure science fiction, the idea of wormholes emerges from Einstein's theory of general relativity. Einstein showed that gravity is not a force but a curvature of space-time caused by massive objects. Just like a bowling ball on a trampoline creates a dip, planets and stars warp the fabric of space and time around them. Einstein's equations allow for the possibility of these space-time shortcuts, these tunnels linking distant regions of the cosmos. If they exist, wormholes could potentially allow us to bypass the vast distances between galaxies, making interstellar travel a reality. Einstein's theories have, truly revolutionized our understanding of the universe. From black holes to gravitational waves, many of his predictions, once thought to be pretty outlandish, have actually been confirmed by observations. But wormholes, well, they still remain elusive, kind of a tantalizing possibility, lingering on the fringes of theoretical physics. One of the biggest challenges is that wormholes, as we currently understand them, are incredibly unstable. They would require exotic matter with negative mass energy density to keep them open. Just think of it like trying to prop open a tunnel through a mountain made of jelly. You'd need some seriously strong scaffolding to keep it from collapsing. Despite all these theoretical hurdles, the possibility of wormholes continues to capture the imagination of physicists and science fiction writers alike. If we could somehow harness their power, wormholes could potentially allow us to travel not only through space but also through time, opening up a real Pandora's box of possibilities and paradoxes. Imagine, just for a moment, stepping into a wormhole, a swirling vortex of energy and light. Instead of traveling through space in the usual way, you'd actually be taking a shortcut through a higher dimension, like a cosmic bypass around the vast distances that separate stars and galaxies. If we could create or control wormholes, the implications would be, well, absolutely profound. We could visit other star systems, explore distant galaxies, and, unravel the mysteries of the universe firsthand. The dream of a galactic civilization spread across the stars would suddenly become a real, tangible possibility. But wormholes present more than just challenges of engineering and physics. They also raise some pretty profound philosophical questions. If we could travel through time, what would happen to cause and effect? Could we maybe alter the past or even change the course of history? The concept of wormholes really forces us to confront the nature of reality and our place in the grand tapestry of the cosmos.